What is the Charles's law?
A law stating that the volume and temperature of a gas are directly proportional.
What causes acid rain?
Similar to smog, acid rain is caused by chemical reactions of pollutants, like sulfur dioxide and nitrogen oxides with oxygen and water in the air. The acidic pollutants formed in these reactions are the cause of acid rain. In addition to environmental pollution due to human activities, volcanic activity can also cause acid rain. Acid rain can be harmful to natural plant life, farm crops, animals, and marine life. It can also be damaging to buildings, depending on what materials were used in their construction.
What is a dative bond?
A chemical bond in which one atom is essentially providing both electrons involved in the bond.
What is insoluble?
A substance that does not dissolve in a solvent.
What is the transition state for a reaction?
The transition state of a chemical reaction is the highest energy structure, through which the reactant molecule, S, must pass to complete the reaction. Since this is the highest energy point along the path of the reaction, this configuration is the most difficult to reach along the reaction path and thus the energy barrier to reach the transition state limits how quickly the reaction can proceed.
What is electronegativity?
Electronegativity is a property that describes the tendency of an atom to attract electrons in a chemical bond. The most electronegative atoms are those which pull hardest on the electron density they share in a bond with another atom. There is more than one scale and definition for electronegativity, and our description here follows that given by Linus Pauling, which is the most commonly used scale in chemistry courses. Electronegativity can most readily be described in terms of the number of protons in the nucleus of the atom and the distance to which its valence electron cloud extends away from the nucleus. As a general trend, the most electronegative atoms are those with the shortest distance between the valence electrons and the nucleus. Electronegativity isn't a physical quantity that can be directly measured, but several scales have been developed that derive values for this property based on other measurable physical quantities.
What is the native state of a protein?
Since there are so many atoms in a protein, there exist a very large number of possible conformations into which a protein can fold. The native state is the conformation in which the protein exists in its natural biological environment. This is most often the lowest energy conformation the protein can adopt. A protein in its native state is able to carry out its biological function, while a protein that is unable to reach its native state often will be unable to do so. If a protein is taken out of a cell, for example, the pH or other factors related to its environment may cause it to adopt a conformation other than its native state.
How do we write an equation for a chemical reaction?
Chemists often write equations to describe chemical reactions. It is conventional to list the initial species, or reactants, on the left side of the equation, followed by an arrow, and the final species, or products, on the right side of the equation. The equation below shows the reaction of methane and oxygen to produce water and carbon dioxide. CH4 plus 2O2 asterisk CO2 plus 2H2O. The arrow to the right indicates that the reactant species are converted to the product species during the course of the reaction. In some cases, reactions are reversible, which will be represented by two arrows, one pointing in either direction, D. Be careful, because in chemistry asterisk is not the same as D.
How does NMR help chemists determine the structure of a compound?
The peaks in an NMR spectrum can be related to certain properties of a molecule's structure. The number of peaks present tells how many types of chemically distinct atoms of a given element are present.
What happens in the frontal lobe?
The frontal lobe is responsible for decision-making processes and problem solving as well as managing your active memory.
How does a breathalyzer work?
When a person blows into a breathalyzer device, the air they exhale enters a chamber containing two glass vials. One is a mixture of aqueous sulfuric acid, silver nitrate, a catalyst, and potassium dichromate. The air is bubbled through this mixture and the sulfuric acid and potassium dichromate react with the alcohol, producing chromium sulfate and other products. The chromium ion of chromium sulfate is green in the solution, whereas the initially present dichromate ion was red/orange in color. The second vial contains the same reactants but doesn't interact with the air sample, thus serving as a standard for comparison. The color change in the sample exposed to the air is monitored by a photocell light sensor system that is then used to determine the alcohol content of the air sample.
What are interferences?
Interferences are substances that interfere with the measurement of the analyte we are interested in. They give a similar response to our analyte in whatever analytical measurement we are making. Typically, analytical chemists want to remove any interferences from a sample prior to making a measurement, or, alternatively, choose the method of analysis carefully, so as to avoid any signals caused by interferences.
What is blood doping in sports?
Blood doping is the act of artificially increasing the number of red blood cells in a person's blood for the purpose of improving athletic performance. This works based on the fact that red blood cells are responsible for carrying oxygen to muscles, and thus more red blood cells can provide more endurance against muscle fatigue. This was originally done by transfusions of red blood cells, either from another person or by collecting and storing a person's own red blood cells to be used later. In the past couple of decades, a new type of blood doping has come about. This is based on the hormone erythropoietin, which stimulates the body to produce red blood cells. Erythropoietin is produced artificially in mass quantities and is commonly used to treat anemia, but is also sometimes used by athletes for the purposes of blood doping.
Why did Frederick Soddy, United Kingdom, win the Nobel Prize for Chemistry?
For his contributions to our knowledge of the chemistry of radioactive substances, and his investigations into the origin and nature of isotopes. Soddy, an English chemist, correctly explained that radioactivity of elements was due to their transmutation, or the changing of one element into another. Specifically, he demonstrated that uranium changes into radium. He also revealed the difference between alpha emission, loss of a helium nucleus, so atomic number decreases by 2, and beta emission, electron emission from the nucleus, so atomic number increases by 1. Finally, the Soddy demonstrated that radioactive elements can have more than one atomic weight, and the idea of isotopes was born.
What is spectrophotometry?
Spectrophotometry is a technique that involves passing light through a sample to measure the fraction of light transmitted or reflected by the sample. This can be useful for determining the concentration of an analyte in a solution or for determining the identity of an analyte present. A law known as Beer's law, see also physical and theoretical chemistry, is particularly important in spectrophotometry. Beer's law tells us that the concentration of a species is directly proportional to its absorbance in a solution. This means that if we know the absorbance of a solution of our analyte at a known concentration, we can determine the concentration of that analyte in any other solution.
Why did Manfred Eigen, Federal Republic of Germany, Ronald George Rayford Norrish, United Kingdom, and George Porter, United Kingdom, win the Nobel Prize for Chemistry?
For their studies of extremely fast chemical reactions effected by disturbing the equilibrium by means of very short pulses of energy. Norrish and Porter were credited with the prize for their development of flash photolysis methods, which applied short pulses of light to initiate photochemical reactions, allowing them to study very fast chemical reactions that could not previously be observed. Eigen's work differed in that he used sound as his form of energy to probe the chemical reactions, which is far less invasive of an approach in the sense that sound does not cause drastic changes in the behavior of the molecules being studied. Of the two methods, the flash photolysis method is much more akin to the modern spectroscopic approaches used today, while sound-based approaches did not gain as much traction.
How is nuclear chemistry different than other types of chemistry?
As the name implies, nuclear chemistry deals specifically with chemical events involving the nucleus itself, while most other areas of chemistry involve rearrangements of the electrons. Nuclear chemistry is focused on radioactivity and the properties of nuclei, and it finds some of its most important applications in energy production, weapons, and medicine.
What is a Nernst equation?
An equation describing the potential of an electrochemical half-cell.
What is enthalpy?
Enthalpy is a measure of the energy that something contains, and it's defined as the total heat content of a system. In terms of chemical reactions, we are most often interested in the change in enthalpy, denoted H, associated with a reaction. The H for a reaction is defined as the enthalpy of the products minus the enthalpy of the reactants, and this is typically measured via changes in temperature that take place during the reaction.
Why do old library books begin to smell after sitting on shelves for years?
The smell of old books is due to hundreds of volatile organic compounds that form from the slow degradation of the book's paper and other materials used in its construction. Acetic acid, vinegar, and furfural, smells like almonds, are two common chemicals ascribed to the smell of old books. Scientists can analyze the volatile compounds to identify the materials used without having to destroy a part of the historical document.
What gives rise to magnetism?
The type of magnetism you're most familiar with. The kind that keeps magnets on your fridge is technically known as ferromagnetism. Ferromagnets are permanent magnets. They generate their own magnetic field. Ferromagnets have unpaired electrons, so from the information in the previous question we can say that ferromagnets are paramagnetic, not diamagnetic. But ferromagnets have one additional key trait: the unpaired electron spins are all aligned in the same direction, which generates a permanent magnetic field. Let's go through this again from the beginning. Electrons have spin, a quantum mechanical property. But we don't need to go that far back, and this spin generates a very, very tiny magnetic field. If all the electrons in a substance are paired, it is diamagnetic. If there are unpaired electrons, the substance is paramagnetic. If there are unpaired electrons and those unpaired electrons are aligned so that there is a net spin for the macroscopic substance, it is a ferromagnetic. Ferromagnets are the magnets, you know, they stick to your fridge.
What is a triple point?
The temperature and pressure at which three phases of a substance are in equilibrium is known as a triple point. The three phases can be solid, liquid, and gas, but can also be two solid phases. Different arrangements of the molecules in the solid and a liquid phase.
What is a chromatography?
A process to separate mixtures, generally by differing affinities of to a solid stationary phase.
Leloir, Argentina, win the Nobel Prize for Chemistry?
For his discovery of sugar nucleotides and their role in the biosynthesis of carbohydrates. Leloir discovered a substance essential for the transformation of one sugar into another. And this turned out to be a sugar bound to a nucleotide molecule, a sugar nucleotide. He soon realized that he had opened the door to a vast number of unsolved problems surrounding carbohydrate synthesis. and proceeded to pursue them with fervor. During his career, Leloir revolutionized the understanding of the synthesis and biosynthesis of sugars.
What is an E factor?
The E factor is a metric of how environmentally friendly, or harmful, a chemical process is. Specifically, the E factor is the ratio of kilograms of waste generated per kilogram of product synthesized. Thus, the lower the E factor, the more environmentally benign a process should be. Of course, this is only a single metric, and other factors, like the toxicity of the waste produced, should also be taken into account. In pharmaceutical companies, the E factor for the synthesis of drug products is typically in the range of about 25 to 100.
What is an atomic orbital?
Atomic orbitals are mathematical or pictorial descriptions of the locations of electrons in an atom. Electrons are tricky particles to understand because their location isn't easy to define. They can be thought of as clouds of negative charge surrounding a nucleus. And atomic orbitals describe the shapes of these clouds. Atomic orbitals can take on different shapes and sizes, but are essentially very similar from one element to the next. The number and type of orbitals that contain electrons play a central role in determining the properties of that atom.
Why do NMR instruments use big magnets?
The purpose of using big magnets is, not surprisingly, to establish a strong, uniform magnetic field in the spectrometer. This creates an energy difference for the nuclear spins that are aligned either with or against the magnetic field. It is this energy difference that is being measured in an NMR spectrum, which can be related to molecular properties like the electron density surrounding a given nucleus.
How can I make a chicken bone flexible?
Chemistry principles encountered in this experiment: solubility in weak acids. Materials you'll need: a jar vinegar, enough to fill the jar, a chicken bone. One from a drumstick works best. The procedure: obtain a chicken bone, and clean it well. Rinse it with water and remove any remaining skin or meat from the bone. Before you soften the bone, try bending it to make sure it is rigid. Don't break it, but test that it is indeed hard. Fill up the jar with vinegar, and drop your clean bone inside. Cover the jar, just so that your whole house doesn't start smelling like vinegar, and let it sit for about 3 days. Recall that vinegar is a dilute aqueous solution of acetic acid, which is a weak acid. Over a few days, the acetic acid helps to dissolve the calcium in the chicken bone. Since the calcium plays a key role in keeping bones hard, the bone will soften once the calcium is dissolved. Remove the bone, rinse it off with water, and now try bending it again. It should be noticeably more flexible than before. Now you can see that without enough calcium, your bones will not stay strong. This might also provide a good indication of why it's a good idea to brush your teeth. If you leave behind any foods capable of dissolving calcium still on your teeth, your teeth may lose some of their calcium and begin to become weak.
Why did Robert S. Mulliken, United States, win the Nobel Prize for Chemistry?
For his fundamental work concerning chemical bonds and the electronic structure of molecules by the molecular orbital method. Mulliken received the Nobel Prize in recognition of his work studying that nature of how electrons behaving in molecules. In particular for the molecular orbital approach that he developed. Molecular orbitals are formed by the overlap of the orbitals on individual atoms. And these can be used to rationalize whether bonds will exist between pairs of atoms. How strongly the pairs will be bonded, and what type of reactivity the molecule may be expected to undergo.
What is Celsius?
Common temperature scale in which the melting and boiling points of water are defined to be 0 degrees Celsius and 100 degrees Celsius, respectively.
Why did Paul D. Boyer, United States, and John E. Walker, United Kingdom, win the Nobel Prize for Chemistry?
For their elucidation of the enzymatic mechanism underlying the synthesis of adenosine triphosphate, ATP, and Jens Skou, Denmark, for the first discovery of an ion-transporting enzyme, Na+, K+AT-PASE. Boyer and Walker shared half of this prize for their work to understand how ATP synthase, an enzyme, catalyzes the formation of ATP. This information bears a crucial relationship to understanding how energy is stored, transferred, and used in cells. Skou received the other half of the prize for his work to discover the first ion-transporting enzyme, which is responsible for keeping the balance of sodium and potassium concentrations in cells.
What is a chirality?
a geometric property of a molecule whose mirror image is non-superimposable with the original molecule.
How much error is associated with electronic structure theory calculations?
There can be a pretty large amount of error associated with these calculations. And the main goal is to keep the errors as consistent as possible and to obtain properties via differences in calculations. For example, the energy of the metal carbon bond in Cr(Co)6 would be calculated by comparing the energy calculated for Cr(Co)6 to that calculated for Cr(Co)5 and Co separated from one another at infinite distance.
How do nuclei spontaneously decay?
Nuclei can undergo several types of decay through spontaneous means without colliding or interacting with nuclei of other atoms. The most common types of nuclear decay are called alpha radiation, beta radiation, and gamma radiation. These differ by the type of fragmentation the nucleus undergoes during the decay process.
What are meteorites?
Meteorites are chunks of material, such as giant rocks, from the solar system that manage to make it to the ground as a larger meteor passes through the atmosphere. Meteors entering from outer space pass through the atmosphere at extremely high rates of speed, from 15 to 70 kilometers per second, and tend to mostly burn up in the process. As they pass through the atmosphere, they may be visible from the ground as a streak of light. And this is what is commonly known as a shooting star.
What is specific gravity?
The ratio of a compound's density to the density of a reference material, usually water for liquids.
How many more Earth-like planets might be out there?
It's hard to say, but considering the tremendous number of stars out there, see below, it's possible that there are a lot.
What is potential energy?
Potential energy describes all of the non-kinetic energy associated with an object. This energy can be the energy stored in chemical bonds, in a compressed spring, or in a variety of other ways. Another example is gravitational potential energy, like that associated with a ball sitting at the top of a hill. Since there are many types of potential energy, there isn't a single equation that describes them all. Since the value we assign to potential energy is always inherently described relative to some choice of a reference value, we can only actually measure changes in potential energy in a meaningful way. A closed system can exchange potential energy for kinetic and vice versa. But the total energy must always remain constant. This is stated in the first law of thermodynamics, which we'll get to soon.
What is a plasma?
A phase of matter in which a significant fraction of electrons have been ionized from their nuclei.
What effects cause deviations from the ideal gas law?
Deviations from the ideal gas law occur due to intermolecular forces between the gas particles as well as the fact that gas particles do actually occupy volume. There is a modified version of the ideal gas law, see atoms and molecules, called the van der Waals equation of state, that uses constants specific to each molecule or atom to adjust for these factors. Deviations from ideal gas law behavior become more important at relatively high pressures and or low temperatures.
What is a crystal?
A solid with an ordered arrangement of atoms of molecules.
What is a saturated solution?
A solution that contains the maximum amount of dissolvable solution, i.e. the addition of any more solution will not dissolve, and will remain in a separate phase.
What is an equilibrium?
A state in which a chemical reaction and its reverse are proceeding at equal rates.
Is lactobacillus harmful?
Lactobacillus is used in the production of lots of foods, actually cheese and yogurt, sourdough bread, pickled vegetables, and wine and beer. There are helpful strains of lactobacillus living in your digestive tract too. So, to answer the question, lactobacillus is not necessarily bad for you in appropriate quantities.
What is irreversible reaction?
A reaction in which the products cannot be converted back into the reactants.
What pollutants do nuclear power plants generate?
Not many, unless something goes wrong. No greenhouse gases, like carbon dioxide, are generated in nuclear power plants. And each only produces roughly 1 cubic meter of waste per year. As long as this is properly taken care of, nuclear power plants are one of the cleanest forms of energy.
Lipscomb, United States, win the Nobel Prize for Chemistry?
For his studies on the structure of borans illuminating problems of chemical bonding. Boron hydride, borane, complexes participate in many interesting examples of chemical bonding. And this is due to the fact that boron possesses one less electron than carbon to donate to chemical bonds, but still often forms 4 coordinate complexes. Lipscomb won the prize for his pioneering explorations of the chemistry and bonding in borane complexes using X-ray diffraction and quantum chemical calculations. He reached a level of understanding of borane complexes at which he could predict the properties and reactivity of borane complexes reasonably well. And his work led to deeper insight into the nature of the chemical bond.
What is vulcanization?
Natural rubber that comes directly from rubber trees looks nothing like your car or bike tires. It's sticky, doesn't hold its shape when it gets warm, and if you live where it snows, it can get brittle. That sounds like an awful material to make a tire out of. Vulcanization creates cross-links in the rubber with the addition of sulfur to the natural rubber chains and improves all of these properties.
What is an orbital?
A possible arrangement for the density of an electron around the nucleus.
How can radioactivity be measured?
Radioactivity is measured by detecting the products of radioactive decay processes. The most well-known instrument used for this purpose is the Geiger counter. A Geiger counter is sensitive to the products of nuclear decay, including alpha and beta particles and gamma rays. The units used to quantify radiation are the Curie or the becquerel, which describe the number of nuclear decays a substance undergoes per unit of time. In many cases, it may not be necessary to directly detect the radiation being given off at this instant, but rather to just determine the isotopic ratio of an element present in a sample. This can be done using techniques borrowed from analytical chemistry, such as mass spectrometry. Information on the isotopic ratio present, along with knowledge of the half-life of the isotope in question, can be related to the age of the sample being studied.
What about blackheads and whiteheads? Are they the same?
Almost. If sebum builds up underneath the surface of the skin, it stays white. If sebum collects around a hair follicle or is in some other way exposed to the air, the sebum undergoes oxidation reactions. As sebum oxidizes, it darkens, eventually appearing black.
What is bronze?
Bronze is an alloy of copper and tin that may contain up to 1/3 tin. Early civilizations used bronze because it could make stronger, more durable tools than stone or pure copper.
What is meant by dynamic equilibrium?
Equilibrium conditions in a reversible chemical reaction are described as a dynamic equilibrium. This means that even at equilibrium the reaction has not stopped, and the forward and reverse reactions are still taking place. The bulk concentrations of reactants and products don't change. But this is just because the forward and reverse reactions are happening at equal rates. The reaction never stops, it just reaches equilibrium.
What about beet and cane sugar? How are those different?
Beet sugar comes from sugar beets. Cane sugar comes from sugar cane. After these two sugars are purified, refined, there is no chemical difference.
What is the azeotrope?
A mixture that does not change composition during distillation.
What is a metalloid?
Metalloid is a term for elements that are sort of metals, and sort of not metals. Sometimes this group of elements is referred to as semi-metals. To be more precise, these elements exhibit some of the physical and chemical properties of metals. Generally, metalloids have some electrical conductivity, but not nearly as much as true metals. Because of these ambiguous definitions, even which elements are called metalloids can vary. Usually boron, silicon, germanium, arsenic, antimony, and tellurium are included as metalloids, sometimes polonium and astatine, rarely selenium.
Why did Theodore William Richards, United States, win the Nobel Prize for Chemistry?
for his accurate determinations of the atomic weight of a large number of chemical elements. Richards was the first American to receive the Nobel Prize in Chemistry. He and his students accurately measured the atomic weight of 55 different elements and also showed that some crystalline solids can contain gases or other solutes within their lattices, technical term, a fluid.
How is the presence of illegal narcotics identified?
Analytical chemists have developed simple chemical tests that can identify the presence of illegal drugs within seconds. Law enforcement officers routinely use these when they are unsure whether someone is in possession of an illegal narcotic. A common field test for cocaine, for example, uses a cobalt thiocyanate complex that turns blue in the presence of cocaine.
How did pharmaceutical science get started?
Paracelsus is credited with being the first person to use chemicals in medicine. Before Paracelsus, people believed that illness and disease were caused by an imbalance in the patient. Hippocrates thought it was an imbalance of the four humors: blood, phlegm, black bile, and yellow bile. And Galen furthered these ideas by assigning a symptom to an imbalance of each of Hippocrates' humors. These theories supported the use of medical techniques like bloodletting. Paracelsus believed that illness was the result of something from the outside world attacking inside one's body, and that some of the illnesses could be cured by chemicals. He is also known for proposing the basis of toxicology, namely that dosage was critical to whether a substance was poisonous or not.
What is the London dispersion force?
A weak repulsive interaction between molecules resulting from interactions of electron clouds.
What is a detection limit?
The detection limit for a measurement is the lowest amount of signal that can be distinguished from the background level of noise. The detection limit is commonly reported with a confidence level describing the percent confidence with which the measured signal at the detection limit can be stated to be above the noise intrinsic to the experiment.
What is a filtration?
The process of removing any solid particulates from a solution.
How much space does the nucleus take up?
The nucleus of an atom takes up a very very small fraction of the total space occupied by the atom. The diameter of a nucleus is on the order of 100,000 times smaller than that of a whole atom.
If fracking is an old technique, why does it seem to be taking off now?
The second key innovation that has allowed fracking to grow so fast in recent years is the ability to drill wells horizontally. Technically, any well that isn't vertical is called directional or slant drilling. Hydraulic fracturing can release trapped natural gas from a much wider area this way, which has led to the recent surge in this technique.
How is the rate of a reaction affected by temperature?
The rate of a chemical reaction will generally increase with increasing temperature. This is because a higher temperature translates into a higher average energy per molecule, which makes it easier for molecules to surmount the energetic barrier to the reaction. In terms of how this fits into the rate equation, the rate constant K depends on temperature. And K almost always, but there are exceptions, increases with increasing temperature.
Is melting a chemical reaction?
No, melting is not a chemical reaction. Melting is a change between phases of matter, and it does not involve the breaking or formation of any new chemical bonds. As the temperature increases to cause a substance to melt, the arrangement of the molecules in the solid/liquid changes, but no chemical reaction takes place. The same is true for liquid to gas phase changes as well as for the reverse processes. Freezing and condensing.
What is the inductive effect?
Polarization of a chemical bond due to transmission of charge through other chemical bonds.
How do chemists study molecules so far away?
Special kinds of telescopes allow astrochemists to perform spectroscopy on the light, or any type of electromagnetic radiation, not just visible light, coming from a star or other celestial body. Certain features of this radiation allow chemists to measure the quantities of different elements and the surface temperatures of objects like stars and comets.
How is hydrogen stored for use as a fuel?
It would be nice if we could store hydrogen as a liquid, however. It has a very low boiling point, minus 252.9 degrees Celsius, which makes this rather inefficient. Due to the strong tendency to evaporate at room temperature, significant energy must actually be expended just to keep hydrogen in its liquid phase. To store hydrogen gas, one possibility is to just compress it inside a metallic container, similar to what is typically done with other gases. There have been several other approaches used, however, to attempt to store hydrogen for use as a fuel. These include both chemical and physical storage methods. Some of the chemical storage systems that have been investigated include metal hydrides, like NaLH4, LiAlH4, or TiFaH2, aqueous carbohydrate solutions, which release H2 via an enzymatic reaction. Synthesized hydrocarbons, ammonia, formic acid, ionic liquids, carbonate compounds, and others as well. These methods generally rely on chemical reactions to make H2 available for use as an energy source. Physical storage methods include cryogenic compression, involving a combination of low temperatures and high pressures, and a variety of materials, such as metal organic frameworks, carbon nanotubes, clathrate hydrates, capillary arrays, and others as well. Unfortunately, few of these physical storage methods have thus far been able to demonstrate strongly promising results in working toward a practically useful method of storing hydrogen as a fuel.
What is nylon?
Nylon is a synthetic polymer formed by the condensation of a dicarboxylic acid with a diamine. This reaction forms an amide bond and releases a molecule of water. The term nylon is a generic name for these types of polymers, but one of the common nylons is called nylon 66. The numbers signify the number of carbon atoms in the amine, 6, and the acid, 6, reactants.
What is an electrochemical cell?
A device that either produces an electric current from or uses an electric current to drive a redox reaction.
What is osmometry?
The process/study of measuring the osmotic strength of a solution.
What keeps an electron from crashing into the nucleus?
Opposites attract, so electrons and protons are attracted to each other, making it somewhat difficult to understand why an electron wouldn't just get as close as possible to the nucleus and crash into it. The key to answering this question has to do with the fact that electrons are very small particles, so they are governed by rules that don't apply to larger objects. As we've talked about a little already, electrons are best thought of as clouds of negative charge surrounding the nucleus. their properties are governed by rules that describe the cloud as a whole, rather than as a single particle. It turns out that there is something favorable about the electron being spread out, or delocalized, around the nucleus. For reasons we won't go into in detail, when the electron's cloud gets packed closer to the nucleus, the energy associated with its motion, its kinetic energy, begins to rise, which makes the situation unstable. There's a balance between the stability associated with placing the electron close to the nucleus, the favorable positive-negative charge attraction, and that associated with spreading out the electron's cloud, to keep its kinetic energy low. This prevents the electron's cloud from getting too close to the nucleus or the electron just crashing into the nucleus.
What is the smallest quantity of lead that can be detected in drinking water?
Lead is something we definitely don't want in our drinking water. The maximum contaminant level goal set by the U.S. Environmental Protection Agency, as of 2011, is 0, indicating that there is no amount of safe exposure to lead in drinking water. The EPA's maximum contaminant level, which is based on more practical considerations, is 15 parts per billion.
How can I use chemistry to make dull pennies shiny?
Chemistry principles encountered in this experiment: surface chemistry, oxidation reactions, materials you'll need. A handful of dull pennies, 10 will do, 1 teaspoon table salt, sodium chloride. 1/4 cup white vinegar, acetic acid solution, a small, non-metallic bowl, water, paper towels or napkins. The procedure: pour 1/4 of a cup of vinegar and 1 teaspoon of table salt into the bowl. Stir the mixture until the salt is completely dissolved. Try first dipping 1 penny into the solution for about 15 seconds and remove it.
What is stoichiometry?
The ratio of quantities in which reactants are consumed and products are formed in a chemical reaction.
What is a bond order?
Number of pairs of electrons shared by two atoms.
Are there alternate theories to the Big Bang Theory out there?
There sure are. While the Big Bang Theory is probably the most widely known and accepted theory surrounding the origins of the current universe, there are still other theories being explored and proposed. Some of these are much more scientifically feasible than others. Take a look around the web and you can find lots of different ideas out there. One alternative that has received notable attention describes the universe as a continuous cycle of expansion and rebirth. The expansion period, similar to that described in the Big Bang, is followed by a period in which the universe once again becomes a dense mass of condensed matter, and then the expansion begins again.
How does the density of snow compare with that of liquid water?
The density of recently fallen, damp snow is approximately 1/10 that of liquid water. This means that 1 centimeter of rainfall and 10 centimeters of snowfall contain approximately the same quantity of water molecules.
Which energy sources are renewable?
Renewable energy sources include wind, hydroelectric, solar, biomass/biodiesel, and geothermally derived power.
What is a flash point?
Temperature at which the vapor pressure of a liquid is high enough that the vapor can be ignited.
How is hydrogen produced for use as a fuel?
Most of the current hydrogen production in the U.S. is carried out by steam reforming natural gas, methane, which involves reacting steam with methane to generate H2, to make hydrogen a viable fuel source. More efficient ways of producing hydrogen on the large scale will be needed. Many scientists are currently investigating chemical and biological catalysts capable of carrying out a process called water splitting, which is the production of H2 and O2 from water, H2O. Water splitting may have the potential to make hydrogen into a viable fuel source for vehicles.
What is heat?
Heat is responsible for all types of energy transfer, other than those that fall under the definition of work. One easy example to think about is ice cream melting on a hot day. Because the ice cream is at a lower temperature than its surroundings, heat flows from the surroundings to the ice cream, causing its temperature to increase, and eventually it melts. There are lots of other examples of heat flow too. It's a pretty big category since it covers all types of energy transfer that aren't defined as work.
What is an electron?
The electron is a negatively charged subatomic particle, and it is one of 3 main subatomic particles. the others being the proton and the neutron, that make up atoms. Electrons are responsible for bonding atoms together to make molecules. And they are also the carriers of electric charges in the conducting materials found in the electronic devices you use every day. While protons and neutrons are both found in the center, or nucleus, of an atom. Electrons are located apart from the nucleus and are best described as a cloud of electron density. Most reactions in chemistry deal with changes to the arrangement of electrons in some form.
So is there any real way to stop onions from making you cry?
Everyone's mother seems to have their own unique proposal about how to avoid crying over diced onions. But there's only one that makes any chemical sense. Excluding wearing a gas mask, put the onion in the fridge before you cut it. Almost every chemical reaction is slower at lower temperature. And since the lacrimator in onions is produced when you cut it, and not naturally present in the onion, you can give yourself more tear-free time to dice if the onion is cold.
What is a boiling point?
The technical definition of boiling point is the temperature at which the vapor pressure of the liquid phase equals the pressure of the surrounding gas, atmospheric pressure usually. This is a precise way of saying the temperature at which a liquid turns to vapor.
What is the Curie point of a material?
As the temperature of a ferromagnetic material is increased, it can eventually become paramagnetic. See atoms and molecules for a discussion of ferromagnetism and paramagnetism. The temperature above which it becomes paramagnetic is called the Curie point. This is actually also a phase transition, though it's not one that's easy to see with our eyes. Such as when water freezes or evaporates.
Who was Marie Curie?
Marie Curie was a famous French-Polish scientist. And she was the first person ever to be awarded 2 Nobel Prizes, one in chemistry and the other in physics. She was also the first woman to ever win the Nobel Prize. And remains the only woman to have ever won 2 Nobel Prizes in different fields. Curie was responsible for much of the pioneering work in nuclear chemistry during the late 19th and early 20th centuries. Much of her work focused on studying radioactive elements, and she discovered radium and polonium. Tragically, it was Curie's work that also led to her death. During her career, the dangerous effects of radiation were not yet known. So she worked without the same safety precautions that would be taken today. Her death was the result of a condition known as aplastic anemia. brought on by her prolonged exposure to radiation in the laboratory.
What did Empedocles believe were the four basic elements?
A Greek named Empedocles, who was not from Miletus, but rather Sicily, was the first to propose the four basic elements. These four elements were earth, air, water, and fire. These elements had a much different definition from that which chemists use today, which we'll get to later. Unlike the modern definition of an element, Empedocles' understanding of an element did not require it to be a pure substance. Water, for example, was obviously not the only liquid Empedocles had ever encountered. Earth represented solids, water represented liquids, air represented gases, and fire represented heat.
What is a peptide bond?
A peptide bond, or peptide linkage, is the bond that links the individual amino acids in a peptide. Have a look at the figure of the dipeptide below. The formation of a peptide linkage is carried out by a structure called the ribosome, which is responsible for generating peptides and/or proteins based on the sequence of nucleotides present in an RNA molecule. We'll get to the details of this process a little later.
What is sublimation?
Phase transition from solid to gas without passing through the liquid phase, e.g., the smoke that dry ice gives off.
What is the role of aqueous hydrogen peroxide as a green reagent?
Hydrogen peroxide, or H2O2, is an ideal choice for a green oxidant because it reacts with high atom efficiency and can react to produce water as the only byproduct. To be a particularly clean oxidant, hydrogen peroxide can be used in aqueous solvents, allowing chemists to avoid the use of any organic solvents. Fortunately, there exist catalysts capable of making hydrogen peroxide behave as an efficient oxidant in aqueous conditions, producing products with excellent purity.
Can molecules have any arbitrary energy?
No, molecules actually have a discrete number of possible energy levels. Another way to say this is that their energies are quantized. To illustrate why this is so different from situations we're used to in everyday life, consider what happens when you're throwing a baseball. You could throw it at any speed between 0 meters per second m/s, and however fast you are capable of throwing it. In molecules, though, only a discrete set of energies are possible. It's as if you could throw the baseball either 2m/s or 40m/s. But not 20m/s or any other speed in between. There aren't many situations we encounter in everyday life in which the possible energies associated with objects come in a discrete set of values.